So for any of these sinusoidal word problems, what's most important is to be able to write out what is the maximum, what is the minimum, how do I find A and K from that, what is like the period length, what is B, and then what is H from that, because those all have a relationship. So again, all text, we can still find out the rule of a function just from text. For 36 months, oceanographers have compiled data on the mass of a humpback whale. So 36 months is just a time period. Essentially, do you remember that question where it was talking about like between 0 and 16? This one's basically saying we're looking within a range of 0 and 36 as of right now. They noted that the whale's mass varies according to the following sinusoidal function. So the 36 month is not the period, it's just the time period at which we're looking at its weight. Important to note that it says initially the whale has a mass of 80 tons. Right now, there's not much I can do with that. I just know that that's kind of like where it's starting. So, okay, maybe able to help me find something. After 6 months, it reaches a maximum of 105. It's like, okay, so it's telling me that there is a maximum of 105. You ever see like maximum? It's basically giving you the max. At the 18th month, the whale's mass reaches a minimum of 55 tons. So it reaches a minimum of 55. Okay. So automatically, because they've given me the max, they've given me the min, I can really just figure out, 105 minus 55 divided by 2. And that's going to tell me what the actual value of A is, right? We're just looking at if this is 105 and this is 55, what's the distance between those two things? 50, right? So then half of that distance is going to be 25, 25. So I know my A value in this case now. So this was 105, this is 55. And then A value is 25. Okay. Now we can kind of figure out what like the halfway mark is, right? We want to figure out our K. And essentially K, if you want to be like sort of formula driven, is go your max minus your A value. Yeah. Would it not just be the 80 since it True. Starts and returns to the same point? Now, if I read the rest of it, yeah, you're right. If you wanted to do it that way as well, in fact, so I'll write 80. I was just doing this first to identify, we can find it mathematically, or if you just continue to read, like you said, at the 24th month, it returns to 80. So then I have a clear beginning, an up, a down, and then it returns back to a certain weight. So you're right. I can either do it mathematically or I can decode it from the question. But now I've got a K. The only other thing to think about now with this guy is I'm just going to draw it on here. So he's starting at 80, and then where does it go first? It's going up, right? Because he reaches the maximum first of 105, and then he reaches the minimum, and then he lands back at 80. Why is that important to this question now? That it goes maximum and then minimum? Because I've got to define what A is. A is either positive or negative. If it's in this shape, right, then A is positive. However, if it hit like its lowest weight first and then reached its maximum, then A would be negative on that guy. So it's just a matter of like being able to decode that this is that scenario. I can put A is going to be a positive 25 in this case. So then now we can go back to that point that you made, Jody, that 24 months, it returns to 80 tons. So that value, 24 months, is your period length, because we're looking at from beginning to an end, when it returned to something. So 24 months. Now I can find B by going 2 pi over 24, which is just pi over 12. In terms of an H value, let's make this easier on ourselves. Initially, so let's say when I ever hear initially, let's think y-intercept. And a y-intercept is going to indicate that my H is going to be 0. if I choose to write it this way, because we will start to get into cosine functions that we can do. So all this was just to kind of decode and now get the rule of, right? Let's zoom back in here. So y is equal to positive 25 sine pi over 12 x minus 0, or just x, and then plus 80. So that is the rule that we can identify, right? Now, it's asking to the nearest tenth for how many months was the whale's mass at least 100 tons. So we are essentially body shaming a whale now. No, excuse me. We're looking for where it hits 100. So when it hits 100, if we think about it right now, if I just actually like kind of sketch this out, let's use a different color up here. What it's essentially looking for is, stop. At 100, right? Which could be around there, let's just say. Everything above that line is what we're looking for right now. Everything above that line. Yeah. So that's basically it. Yeah. We always kind of set it that way. So we run through it in this situation where now let's find the x's when the y is 100. So I'll do, right, y is equal to 100, 25 sine pi over 12, x plus 80. So then you're right. I'm going to set this guy, or sorry, typically, well, when we were doing quadratics, we would set to 0 and then plug into a formula. This guy, what's more important actually is let's isolate, and we're always trying to isolate for sine bxh, right? So I'll even add that here, like write that down. Our goal is to isolate for sine b x minus h when solving for x. So that means bring this guy over first. 20 is equal to 25 sine pi over 12x. And again, I'll highlight it. We are trying to isolate for that. There's no h in this case, but if there was, we would try to include it, which means at this stage, I will be dividing by 25 on both sides, right? So here's where the calculator version is going to come into play, right? Like if I go 20 over 25, what if I wanted to leave it as a fraction and see if this kind of helps me in some sort of way? What could I reduce it to? Well, I could reduce it right to 4/5. But like if I go to my unit circle, can I find 4/5 anywhere? It's not on there. So this is where the calculator method, so I'll put calc method, that also involves this lovely cast system, right? 0.8 is equal to sine pi over 12x. So because I've now isolated for that thing I was talking about, sine bxh, now my next step, and choose to write this whatever way you want, but my next step is going to be to write out sine minus 1 of 0.8, right? So then sine minus 8, shift sine 0.8. And I get something like, and I'm in radians. Make sure you double check that too. I get something that theta, and you can write it like this here, because essentially what we're doing is we're finding theta. We're finding an angle that we can use for that cast system. So in radians, the angle is 0.927. Okay? It's a positive value. And if I go take a look at this guy here, right, this cast system, right, what we can do is say that CAST, where is it going to be positive? Right there and right there, right? There's going to be two answers. There's going to be two angles. They're going to exist in the A and the S quadrant. you want to label them as such. Meaning finding this angle theta is pretty easy, right? So answer 1 is going to be, so we can take this guy and split it off into two things. 0.927 is equal to pi over 12 x. And additionally, so we'll be able to solve for that. If I'm looking for this angle, well, technically, I'm not looking for that theta. Technically, I'm looking for from there to there, right? I want to find both this angle, which I did, just 0.927, as well as that second angle. And the only way for me to figure it out, because the only thing I know is that theta was returned at 0.927, this will be pi minus 0.927 is equal to pi over 12x. And then now all we do is basically just let's use our calculators to be as accurate as possible, keeping with our decimals. And I can write out 3.142 minus 927. And then let's stick with the decimal land here. 0.262x. And then up here, 0.927 is equal to 0.262x. And then we're basically just going to go 0.927. So this one's going to be something like 2.215 is equal to 0.262x. And we're still going to divide by 262 on either side. 0.262. So divided by, and get a answer of like 8.45. Because what did it say? To the nearest tenth of a decimal we're looking? What was the question I asked for? To the nearest tenth. Okay, so let's just round it to, here is x is equal to 8.5. And then 0.927 divided by 0.262 is going to give me, right, divide on both sides here, 0.262. My x is going to be equal to 3.5. So we now have kind of like the sort of beginning and end. If I go back up to my little sketch drawing up here, right? If we kind of draw a line here and say this is where y is equal to 100, then I know that this x value exists at 3.5 and that x value exists at, what did it say, 8.5? So because of the nature of the way this works, okay, and because we also looked for 36 months, so this is going to be tricky to add in the extra layer of it. For how many months was the whale's mass at least 100 tons? If we were looking over 24 months, how long was it above that line? Just 8.5 minus 3.5, right? We're just looking at the distance from what is the distance between 3.5 and 8.5? We're just strictly looking at that piece of the function right there. Here's the only problem now. This is looking at 24 months. Let's get rid of this here. This crappy drawing that I made, which I should have done a better job of, that's 24 months, meaning I've got to add on 12 more months to get to 36, right? And if I did that, knowing the way that this guy works, knowing that 12 is half of the period, right? The rest of this function, let's do it in green again. The rest of the function going to go up and then down again, right? This was halfway. Those two pieces would be symmetrical with each other. So in terms of, let's think about over the time period of 36 months, it wasn't just 3.5 to 8.5. We also had to take into account this section of it as well. So if this distance was 5, this distance is also 5, meaning in total, right? Total, it would be 10 months that she was above 100 during the 36 months that we looked at it. So that's the only part about these guys that gets tough. If you get to the 3.5 and the 8.5, I'll be absolutely pumped, right? 8 out of 10, 9 out of 10, depending on how you do. This last reasoning part, taking into account like the period that we're looking at and applying that, that's just like that's icing on the cake for right now. My main objective is that you're able to take something like this and get the two x values. Let's make sure that we can do that.